What we're going to cover for this part is basically the key concepts that are important integration techniques. So now before you do the challenging parts, what I would recommend is that to make sure that you know the basic formulas of integration, like the basic integration formula, like x raised to n integral is x to the power n plus 1 or n plus 1 integration. Also the one which is with the transform linear integration part. So let's say if you're integrating ax plus b to the power n, the integration is ax plus b to the power n plus 1 over n plus 1. So and divided by coefficient of x, that is a. So this is just one of the example that I'm giving, and there's one detailed work that I have covered in my previous lesson also about how to do integration of the basic linear functions raised to power n, or for example, let's say if you've got something like sine ax plus b, how do we integrate these things? So this is mainly about the AHL syllabus that we have. Now the additional formulas that you got to know is these formulas are also in a data booklet. You can refer them. Now, there are some of the reverse ones, like if you know that the arc sin x derivative is this, arc cos x derivative is this, arc tan x derivative is this. So the expression, direct expression might not be you might not be able to see it in the exam, I mean the data booklet, but you have some relevant formulas. If you go backward or forward, you can find out the required formula. Now, one of the formula that has been included new for AAHL syllabus explicitly is the a to the power x integration, which is the integration of a to the power x is a to the power x over ln. So now let's say if I'm integrating, let's say a to the power 3x plus 5 or something. Now where a is a number, let's say I'm integrating 5 to the power 3x plus 5. This answer is going to be more or less of e to the power ax plus b type. So it is going to be 5 times, it will be 5 to the power 3x plus 5 over 3. That's the coefficient of x. And obviously don't forget to do ln a, which is the ln of this number. So this is the integration of basic stuff. Now, in case if you're confused with some of the integration skills, I still recommend to watch the first series on this, like integration techniques. Now, what I would be using is mainly these formulas to solve for the different techniques like integration by substitution. Now, if you look at the integration by substitution here, the first thing is that these are the types of basic standard level type questions. This is, I would say that this has been explicitly given in IB mind map because that you should know how to change the limits. That's what is the skill they're talking about. So let's just take example on integration by substitution here. So now, for example, let's say if I'm integrating e to the power x over e to the power 2x plus 9. Now, when you're doing such questions, let's say I'll just kind of first create some space. So I'm, let's say, doing e to the power x or e to the power, let's say, 2x plus 9. So e to the power x or e to the power 2x plus 9. So this is the expression, and here we are supposed to integrate within the limits 0 to ln3. So when you're integrating from 0 to ln3. Now, whenever you're doing the substitution, now lots of times it comes to your mind that what substitution should we take? So generally, here when I take the substitution, let's say I'm taking u is e to the power x. The general substitution skill is that, okay, whatever substitution you're making, at least derivative should be as a multiplier in the function. So now, for example, if I've got x squared e to the power x cube or something, this kind of question I've explained in my integration by substitution lesson. So if I'm, let's say, finding out the derivative of x cubed, that is 3x squared. So at least I have x squared, so I can make the substitution for it. But if I'm substituting entirely this expression, that'll be wrong because the derivative of e to the power x cube I don't have anywhere. So in this case, I can see clearly that the derivative of e to the power x I already have as e to the power x. So I can go ahead with the substitution. Now, once you're making the substitution, what is really important is that you got to have the limits in right place. So lots of students make mistake that, okay, even after taking the substitution, they'll keep the limits the same. These are the limits for x values, not for u values, remember that. So what we do is you're going to obviously find out du by dx, which is e to the power x. Now, dx is nothing but du over e to the power x. Now I'm just going to put it back here. So what we get is that, okay, 0 to ln, this is the mistake that you make. Now, if I keep the limit same, I'm going to correct this limit. But just right now, I've got e to the power x here, 9 plus u square, and times du upon e to the power x. And the reason we search for this derivative of the substituent is basically so that they get cancelled, which you can clearly see here. So now I got integration, which is du over 9 plus u square from 0 to ln3. From 0 to ln3. Now what you guys do is that in case now here, this is the ln3 is retained throughout, you'll get m0 mark here, a0 mark here, b0 mark here. So none of the steps are getting correct. Actually, if you're making this mistake, that's what I say is that explicitly address this issue in the right in the beginning when you make the substitution. So I'm just writing with the red marker here. But if I have got u as, let's say if I got u as ln3, now when I get u is, suppose let's say if I have x is ln3, u is going to be e to the power ln3. Now first find out the respective values. Now this value, as you know, is the property of log and ln concepts. The answer is 3. And now once you have got 0, it is, if I take, let's say when x is 0, my u is nothing but e to the power 0, which is 1. So actually this integration limit is not 1, I mean 0 or ln3, it's 1 and 3. So either you don't include in limits anywhere, and at the end when you substitute back the integration, then you take the limit. Otherwise, don't do this. Don't continue with the wrong limits, because you lose out all the marks in the intermediate steps. Now I got 0 to ln 0 to 3 here. Let's say 0 to 3. Now 1 to 3 actually. I'm going to integrate this. So integration that I have to do is 9 plus u square from 1 to 3. Now this integration, as we see, is one of the format of this one. Let's say du over a square plus u square, which is nothing but 1 over a tan inverse of u over a. So this is going to be 1 over a, which is 1 over 3 times tan inverse of u over 3. So because a is nothing but, if you see here, compare, a is nothing but 3 square plus u square. So a is 3. So that's how I got a is 1 by 3 here. A is 3. So 1 by a is 1 by 3. Tan inverse of u by 3. Now, since it is a definite integration, you got to put the limit substitution now. So take now u as 3. So it'll be 1/3 tan inverse of 1, because if you take u as 3, that's your this answer, minus 1/3 tan inverse of 1/3 itself. So this answer is this is what you get. So this answer is 1/3 tan inverse of 1 is, is pi by 4, minus tan inverse of 1/3 you don't know. So keep it as it is. So tan inverse of 1/3. So this is a simple substitution example that I have taken, where you have to be very careful about the limits. And hopefully you have understood this. So now the second type of integration that is actually the proper AHL type questions are actually these integration substitutions. Now, whenever you take the integrations of the format, let's say root a square minus x square, or x square minus a square, or root a square plus x square, these are the general substitutions you take. X is a sine theta, or a cos theta for that matter as well. When you have x square minus a square, it is x is either a sec theta or a cosec theta. Here, if you got x is a tan theta, you take either a tan theta or a cot theta. So these are the substitutions we make, and there is a reason for that. I'm going to take an example to demonstrate that. I won't be able to do all of these, but at least 2 examples in quick thing I'm going to take here. So let's take first one is when I'm integrating something called as root of a square minus x square type. So I'm just going to take, let's say if I'm integrating root of 4 minus x square, and I have to write an exact answer. So since it is of the format a square minus x square, now what basically I'm going to try to do is I'm going to just get rid of the square root. Now I just want to quickly remind you about the inequalities that you have. So let's say first thing is that 1 minus cos square theta is sine square theta. And 1 plus tan square theta is sec square theta. And 1 plus, let's say 1 plus cot square theta is cosec square theta. Now what happened is that here actually what you're trying to do is you're basically trying to get rid of the root with a clear substitution. Now, if I can get something like here, if I have to, let's say, get rid of something in the root here, let's say root of 1 minus cos square, I can see that, okay, root of sine square, that is nothing but sine theta. So then I can get an easy way to integrate this. Now, since I don't have any formula for this, now I can clearly look at it that, okay, if I can get this in form of something like 4 minus 4 sine square theta or something, and then I can take 4 common, and I can make it 1 minus sine square theta, and then it become, okay, it is 2 cos square theta root, and it is 2 cos theta, and then I can get a simpler integral. So that's what is the objective of figuring out that, okay, why do we take x as, let's say, a sine theta or a cos theta. So I'm just going to quickly take now a substitution here so that I can show the entire process. So let's say x is a sine theta when I take here. Does it mean that I can't take a cos theta? Obviously, I can take a cos theta as well. So x is, let's say if I take here, my a value that I can figure out is something as 2. So 2 sine theta, or here I take is, let's say, 2 cos theta. So now when I do this, now I have the first thing that as a challenge is that how do I get rid of dx? So I get rid of dx obviously by, let's say, I'm just going to take 2 sine theta substitution. So I'm just going to differentiate dx is nothing but 2 cos theta here. Now as a result of this, what happened is that if I make, let's say, dx a subject, it is 2 cos theta d theta, and that comes out here. So sometimes you don't do this treatment for dx and you get all the answers wrong. So you get here, now root is 4 minus 4 sine square theta times 2 cos theta d theta. Now when you simplify this, it is 2 times root of 1 minus sine square theta times 2 cos theta d theta. So this can be written as further 4 times sine 1 minus sine square theta is cos square theta times cos theta and d theta. Here's square root of this. And as a result of this, now what we get is 4 cos square theta d theta. Now, once again, here, the little bit of trouble is because I don't know the integration of cos square theta straight away. So I'm going to use the double angle formula. Remember that cos 2 theta for double angle is 2 cos square theta minus 1. And that results in, if I make cos square theta the subject, it becomes 1 plus cos 2 theta over 2. So similarly, if you've got sine square theta as somewhere to integrate, you can write down 1 minus cos 2 theta over 2. So remember, these two is standard substitutions that can help you to save some time in exam. So I'm just going to put cos square theta as this, and what I get is 4 times 1 plus cos 2 theta over 2 times d theta. So you can take 2 and 2 cancel here. So you get 2 times 1 plus cos 2 theta and d theta. Now, as a result of this, now what we get is 1 integration is nothing but theta, and cos 2 theta is nothing but sine 2 theta over 2. Now, once again, our responsibility back is to substitute back the values. So it is 2 theta plus sine 2 theta and plus c. Don't forget to write on plus c. So now we got to do the substitution back here. So we had taken x is 2 sine theta. So if x is 2 sine theta, I'm going to substitute back its values. So x is 2 sine theta. So sine theta is x over 2, and theta is sine inverse of x over 2. Now here we get, okay, so 2 times of sine inverse x over 2 plus now sine 2 theta is actually, I could use the double angle formula, which is 2 sine theta cos theta plus c. Now sine theta we know it's already x. We just got to find out the cos theta, so you can use the triangle. This is theta. So if I take this as x over 2, this is going to be root of 4 minus x squared. So what we get is 2 sine theta. So it'll be 2 times x times cos theta is root of 4 minus x squared over 2. This 2 and 2 get cancelled. So as a result, my final answer for integration of root 4 minus x squared dx is, that is 2 sine inverse x over 2 plus x times root 4 minus x squared plus c. So this is a basic one of the substitution that involves trig identities. I hope this part you remember. It saves at least your 5 minutes in the exam time.